plan for an exceptional, enormous occasion not too far off. A red monster star situated at the edge of our universe is producing puzzling signs. Across the universe, using the James Webb Space Telescope, stargazers have made agitating disclosures about this enormous divine body. Prestigious astrophysicist Brian Cox issues a serious admonition, bringing up the issue. Are we near the very edge of seeing a disastrous cosmic explosion blast that could forever adjust our night sky? How about we dive into the subtleties in the tremendous territory of the universe where stars come to life, flourish, and at last meet their end in a stunning showcase? One star has as of late caught the consideration and worry of space experts and people in general the same. That star is Betelgeuse, a red very monster of tremendous extents and mature noticeably situated in the Orion group of stars. While its extraordinary ruddy tone and shifting brilliance have long captivated spectators, late turns of events have heightened interest in the divine Goliath. As we investigate the nature of Betelgeuse, we think of ourselves as on the edge of a possibly great occasion in the star's life cycle. But what could these progressions in Betelgeuse connote? Are we seeing the introduction to an incredibly excellent enormous scene? Betelgeuse, multiple times bigger than our sun, remains as a heavenly behemoth of titanic size, nearly beyond human perception. Imagine a star so tremendous that if it were to supplant our sun, its surface would stretch out past the circle of Mars, wrapping Mercury, Venus, Earth, and Mars in its heavenly hug. This astounding size not just exhibits Betelgeuse's actual traits, but also highlights its stage in the heavenly life cycle as a red very Goliath. Betelgeuse is in the sunset of its presence, marked by expansion and cooling after a life expectancy combining hydrogen into helium in its core. In spite of being moderately youthful in human terms, at around 8 to 8.5 million years old, Betelgeuse's ongoing red super Goliath stage is the consequence of millions of years of heavenly development, changing from a hot blue star to the red Goliath we see today. Betelgeuse's unmistakable ruddy tone comes from its cooler surface temperature compared to stars like our sun. While the sun's surface temperature is around 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,000 to 3,500 Kelvin, emitting light at frequencies that give it a red appearance. This tone isn't just visual but offers insights into the star's state of being and the cycles within its vast gaseous region. Adding to Betelgeuse's persona is its historical variability. Ancient Roman and Chinese writings suggest it was a yellow star around 2,000 years ago, with Arabic scholars first describing it as red in the 9th century. This variability shift over mankind's set of experiences gives significant insights about the star's evolutionary path. The variable brightness of Betelgeuse is equally interesting. As a semi-regular variable star, its light periodically waxes and wanes in a trademark dance of glow following a multi-day cycle and a longer cycle spanning around 5 years. These cycles have been documented since 1836 by Sir John Herschel and possibly much earlier in native oral traditions. However, what adds to the mystery of Betelgeuse isn't just its changing brightness but its unpredictability. Unlike many stars that follow a predictable pattern, Betelgeuse sometimes strays from its rhythmic dimming and brightening, indicating complicated and less recognized processes within its giant structure. In a new pivotal discovery, Betelgeuse caught the attention of astronomers and stargazers worldwide with an unexpected and sensational change in its appearance, widely known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the most brilliant stars in the night sky and a prominent feature of the Orion star cluster, began to strangely fade. The star's diminishing was so pronounced that it started losing its radiance at a normal pace of 0.1 sizes each day, reaching its lowest brightness in February 2020. Betelgeuse, regularly visible to the unaided eye even in light-polluted areas, became noticeably fainter, a change even amateur spectators could discern. However, there's a challenge when trying to monitor Betelgeuse's activities: the time delay when we observe a star. We're not seeing Betelgeuse as it exists in the present but as it was in the past due to the time it takes for light to travel to us. For Betelgeuse's situation, approximately 725 light-years away, the light we see today left the star almost 7 centuries ago. This delay makes it hard to predict and monitor sudden changes in a star's behavior as we are essentially looking into its past. Andrea Dupree, related overseer of the Center for Astronomy at Harvard and Smithsonian, and her team closely observed the unfolding divine show. Using the Hubble Space Telescope, they examined the behemoth star as part of a 3-year study to monitor variations in Betelgeuse's outer environment. These observations provided unique insight into the dynamics of a variable star like Betelgeuse, which regularly expands and contracts, causing fluctuations in brightness. Hubble's aversion to bright light allowed researchers to sample the layers over the star's surface, heated partly by the star's stormy convection cells. Further analysis of the Hubble spectra taken at different times throughout 2019 and 2020 helped measure the movement of material in Betelgeuse's outer atmosphere, specifically focusing on magnesium Roman II lines indicative of the star's air conditions. These observations revealed material moving at velocities of around 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually expanded thousands of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's darkening. Dupree and her team estimated that about 2 times the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the eruption. This mass loss was significant, especially considering that Betelgeuse, like all stars, regularly loses mass but at a rate far greater than that of our Sun. The size of this mass ejection and the subsequent darkening sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. The proximity of Betelgeuse, around 725 light-years from Earth, adds to the interest, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. Yet the question remains, what does this darkening event portend for Betelgeuse's future? Is it a harbinger of an impending supernova explosion or simply a unique episode in the star's long life? Several theories were proposed to explain this abrupt change. One pervasive theory suggested a phase in the supernova explosion process gaining traction due to the common belief that Betelgeuse is nearing the end of its life. Another widely discussed theory highlighted the possibility of dust possibly originating from Betelgeuse itself obstructing our view. Red supergiants like Betelgeuse are known to shed material, and it was suggested that this material could form a dense dust cloud, causing a dimming effect when observed from Earth. Another explanation considered changes in the star's photosphere, the visible surface layer, which could affect its apparent brightness. To unravel this mystery, an investigation using various observational techniques was employed. Spectroscopic studies revealed the decrease in Betelgeuse's effective temperature, indicating that the dimming may be attributed to a large dark spot on the star's surface. It was the observation that Betelgeuse's temperature decreased by at least 170 Kelvin around the time of the dimming, suggesting significant surface changes. Ultimately, the breakthrough in understanding this peculiar event came from the Hubble Space Telescope. Hubble's observations showed that Betelgeuse's dimming was likely caused by a massive ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, reducing the amount of light reaching us from Betelgeuse. The dust cloud was believed to have originated from very hot plasma ejected from a large convection cell on the star's surface. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, starting in January 2019, played a crucial role in piecing together the timeline leading to Betelgeuse's darkening. These observations captured signs of hot, DSE-heated material moving through the star's atmosphere in the months preceding the dimming. In December 2019, several ground-based telescopes observed the star dimming in brightness, particularly in its southern hemisphere. The material, initially brighter than the star's normal brightness, eventually led to the formation of an ominous shadow as it moved outward and cooled. The theory proposed that this outflowing material and the resulting ominous shadow caused the sudden dimming of the star. The magnitude of this change was truly monumental, pushing Betelgeuse into the galactic spotlight. The star expelled an estimated 400 billion times the mass normally produced in a standard coronal mass ejection. This expelled material, believed to be several times as much as our Moon, was a significant event not only for Betelgeuse but for ongoing how we might interpret celestial mechanics. What implications does such a massive ejection of material hold for Betelgeuse and supernova theories at large?